fly the historic voyage of Europe's brand new launcher. Joshua Jampel here, along with Davide Nicolini from ESA, the Deputy Launch Campaign Manager for Vega. Greetings, and a big day for you.
Wow, yes, big day today and a long night.
A long night?
We've been here since midnight, chronology. Everything's going very well.
Very well. Okay, we have a lot of films tonight. Our first with Jean-Jacques Dordain, the head of ESA, for some opening words.
Bonjour, bienvenue à ce
Hello, and welcome to this important event. And it is indeed important, this maiden flight of Vega, the qualification launch for the recent addition to our growing family of launchers, with Ariane, Soyuz, and now Vega. It's a launch vehicle that we truly need, and that we have taken 10 years to develop. I'm indeed well placed to say that, as I was Director for Launchers at the time. I signed the Vega development contract with Mr. Fabrizi, who was then working for industry. And we are both still here today, although in different positions. The launcher began its life in Italy, but very quickly became European, so as to draw on industrial capabilities not only in Italy, but also elsewhere in Europe. All of this has required tremendous work over these many years, and particularly over the last few months. So, we're now all ready to go, and I will be back with you after the launch.
Over 1,000 people from 40 European countries and industries have been working on the development of the brand new launcher. Davide, what's the most important thing people should know about Vega?
Well, it's important thing is the third time Europe will develop a new launcher. Started with Ariane-1, Ariane-5, and now Vega. So it's an important moment for Europe, I guess.
More in a moment. First, a word from Jean-Yves Le Gall, chairman of Arianespace. We'll be back.
Good morning. Today is a particularly important day for European space because after almost 10 years of hard work, we're now ready for the very first launch of Vega. Vega is on everybody's mind today, but it was Arianespace that adopted it several years back when we introduced the concept of a launcher family. In addition to Ariane 5 and Soyuz, we now have Vega, the light lift launcher, ESA's small launcher of the future. I would like to thank everyone involved in the past 10 years of effort, starting, of course, with the engineers at ESA and those at the Italian space agency ASI, because, as you know, Vega's origins are Italian. My thanks also go to the CNES engineers who developed the first stage, called the P-80, here at the CSG, and to all the many industries throughout Europe which have been involved in this program, and of course to the Arianespace teams who are involved in today's launch. Vega is going to be extremely important for Arianespace because in just a few years it'll be the only vehicle of this category present on the commercial market. The reason for that is because what we call small launchers today, those of the Vega class, capable of carrying Earth observation and scientific spacecraft of 1 ton or 1.5 tons to an altitude of 1,000 kilometers, well, they are in fact all former ballistic missiles that have been reconverted. They were manufactured a long time ago and will soon reach the end of their lifespan. So in just a few years, Vega will be the only launcher to exist on this market. And Arianespace has already signed 2 commercial contracts for 2 Vega launches in the coming years. So you see, today is indeed a very, very important date. But without further ado, I'll leave you now to enjoy the first launch of Vega from the CSG.
Outside Vega on the pad, it's early morning here local. Davide, we have a reasonably comfortable launch window, over 2 hours.
Yeah, today the launch window is determined by the fact that we need to have the launcher in sunlight all over the trajectory, all the way up to the LARES separation. So that's why it's 7 a.m. all the way up to 9:30.
Because we have cameras.
We have cameras, qualification flight.
The new Vega launcher has a rich history. Antonio Fabrizi, ESA's Director of Launchers, will tell us all about it.
Its name has a double meaning. Vega is the second brightest star in the Northern Hemisphere, but it also means, in Italian, the European Advanced Generation Carrier. Though the name is in the heavens, part of Vega's roots lie in an earlier American rocket called Scout. In 1964, Italy was first in Europe to orbit a satellite, using the U.S. vehicle from Wallops Island, USA. Later, through the late 1980s, it flew from a platform off the coast of Kenya called San Marco.
They made some 10 launches from Kenya, and at the end of the 80s, when it was felt that there was a need of a small launcher for Europe, then the idea was just to improve the Scout launch vehicle by adding motors that would be derived from the boosters of Ariane 4.
That idea changed. Instead, the Europeans opted for something totally their own. A launcher for small satellites, yes, but one entirely based on know-how developed within European industry. In particular, Vega would be built on technologies in solid propulsion provided for the boosters on Ariane 4 and Ariane 5. The Vega program got going in the late 1990s. At that time, another Italian project called Zefiro was developing even bigger boosters with a new technology mainly based on carbon filament winding. Zefiro became the backbone of Vega and was used in its ultimate design as the second and third stage engines. Vega's maiden voyage is its qualification flight, the one remaining technical test. Antonio Fabrizi, one of the fathers of the Vega program, can look back now on all the technical trials, but also on the political challenges.
The technical is something that we as engineers are more used to deal with. The political problems are less predictable sometimes. With the duration of 10 years of development programs of this nature, of course we go through several governments in several countries, and it's difficult to keep together the political team of the concerned member states for a so long period. That's an important challenge, even more than the technical.
Vega extends Europe's family of launchers, adding to the successes of Ariane and Soyuz, and opens a new page in European space history.
That new page opening with today's flight, which is a qualification flight, not a commercial one. What does that mean exactly?
Yeah, today we're going to be qualifying the launcher, but also all the overall launch system. That means all the ground segment and all interaction with the base. So it's an overall important qualification.
So we're looking at separation systems and
everything from a launcher point of view.
Things are different here at the space base because of Vega. The CSG's director, Joel Barr, has more.
With the coming of Vega, Europe's spaceport now has a full family of 3 launchers. Among the many changes Vega has brought to the space base include several new facilities. But her arrival has also signaled new and different working methods inside these facilities for the increased numbers of experts operating here. The space base must be ready, for example, to carry out 3 launch campaigns at once and in parallel for Ariane, Soyuz, and Vega. This means teams that can reach across borders.
We have new facilities that we have built or reactivated to operate these 3 launchers and their payloads. Right now we are in the middle of preparing 3 launch campaigns in parallel. We're relying on Ariane, a Soyuz and a Vega campaigns. It all means a lot more activities and facilities, and all that must go in harmony with teams that will become polyvalent, because they are the same teams that must be adapted to Ariane, Soyuz and Vega, according to the launch operation we lead. And we do this in synergy with the most efficient method possible.
Et c'est ce que nous faisons en synergie, donc de manière à effectivement le faire avec le meilleur rapport coût-efficacité.
With this first launch of Vega, we are going to have the launch of a new vehicle and its qualification flight. We launched our first Soyuz last October, but Soyuz has more than 1,780 missions to its credit, so it was not a new launcher. Vega is a completely new vehicle.
Davide has left us momentarily to return to his post inside the fishbowl and to be with his teams. He'll be back up here in the booth after extinction of the first AVUM, which is the fourth stage burn, about plus 9 minutes from now. A look at the launcher, 3 stages with solid propellant, and the upper stage called the AVUM. Davide will explain all that when he gets back, is a liquid propellant stage. The stages are stacked on top of each other on the launch pad. We'll come back and describe each of these in turn while they are functioning. Let's a quick look at the launch vehicle. LARES, the primary passenger, has gone on internal power now. For another thumbnail sketch, a better one than ours, on Vega, we go to Stefano Bianchi, Vega's program manager at ESA.
Vega is called a small launcher, but in fact it's not that small at all. It stands over 30 meters tall and weighs in at over 130 tons. It has 4 stages, 3 of which work on solid propulsion.
We have a first stage of 88 tons of propellant, solid propellant, which is also one, is really the state of the art for this kind of solid rocket booster, because it uses a composite structure, a very light structure, and is the biggest monolithic composite structure solid rocket booster in the world. Then we have a second and third stage, which are called the Zephyr stages, with 23 tons and 11 tons for the third stage. And the fourth stage is an AVUM based on liquid propulsion, which hosts all the avionics of the launcher, and we end up with fairing, which hosts the payload.
The launcher is integrated within a mobile gantry, and this mobile gantry is then moved 80 meters aside before liftoff. This is the same principle which was used for Ariane 1, 2, and 3. Vega will launch from the same spot where these Arianes lifted off during the first decade of Europe's flights from the French Guiana base between 1979 and 1989. The historic launch pad has been rebuilt specially for the new Vega vehicle.
Coming up on 6 minutes to go before this historic first launch of Vega, you saw Mr. Bianchi and Mr. Fabrizi there. We gave you a quick first look at the launcher. Now for a look inside the fairing to see how the satellites are carried for their mission or missions. There are 9 passengers, a rather complex mission for a qualification flight. We'll be back with some facts on that. Primary payload is LARES. The secondary, and secondary only in the sense that they're separated in second position. Secondary passengers are ALMASat-1 and the 7 CubeSats. LARES will be separated first. It's both the upper passenger and the heaviest at 400 kilos. ALMASat weighs in at 12.5 kilos, and each of the 7 CubeSats 1 kilo each. You've seen the launcher and the satellites. For a more detailed look on Vega's first mission, we turn to Michel Debrenne of Arianespace.
This is the qualification flight, so it's our first launch. We will be qualifying the entire Vega system, the launch vehicle, the ground segment, and also the payload transportation system. 9 satellites are to be launched, LARES, ALMASat, 7 CubeSats. What is more, because of the specific trajectory, we need to have 7 tracking stations. So on the ground side too, it's a complicated campaign. 9 payloads on the maiden flight. This launch will be very fast. The first stage has a thrust of 300 tons. Burn phase will last around 2 minutes. Then comes the 23-ton second stage with its 120-ton thrust for 1 minute, followed by the 10-ton third stage with a 30-ton thrust. So you can see how rapid the burn phase is for the first 3 solid stages, about 6 minutes. After this we move into a more tranquil phase with the liquid stager AVUM. LARES will be separated about 1 hour after 55 minutes. Then a minor deorbit maneuver will allow it to lower the orbit and jettison the next passengers, ALMASat and the CubeSats, into that lower orbit.
C'est-à-dire ALMASat et les
À
CubeSats.
12 de DDO, attention pour la séquence finale lanceur.
You're hearing the DDO about to call out the 4-minute mark.
Top. H0 moins 4 minutes.
The 4-minute mark tonight is the beginning of what's called the synchronized or automatic sequence. You heard Michel Debrenne just a moment ago in the film say the initial powered flight sequence of Vega's first 3 stages occurs rather rapidly in roughly 5 minutes. Ariane 5 sequence is longer, if you're familiar with that. Also, unlike Ariane, Vega has a short automatic or synchronized sequence. Ariane's, you might remember, is usually 7 minutes. Tonight, 4 minutes. The DDO, or Range Operations Manager today, ALMASat, the first female DDO we've ever had. This is her second mission. Her first was last September on Ariane's flight number 204. The 4-minute mark, which she called out, is the beginning of a complex series of operations running right down to liftoff, gradually letting the launcher become autonomous as power passes from the ground to the onboard computers, which will control everything afterward. Our cameras are here in Jupiter Mission Control Center, but a lot of people are at work at a lot of different places across this big space base, and you're looking at one of them now. This is the CDLV, the Launch Operations Center for Vega, where the Launch Operations Manager and his teams are right now. That's Davide on the right there, he's down there. They are much closer to the launch pad than we are here in Jupiter. The COEL leads about 100 people who are at this moment going over the final checks and verifications on all parts of Vega's launch system, piloting things until liftoff. And then Vega is on her own. You're watching the inaugural flight of Vega from Europe's spaceport. You can follow it all on the ESA website on ESA TV. There is the helicopter shot, because on the qualification flights, as Davide was saying earlier, we have a lot of cameras because we want to look at everything. We need good visibility today because we got cameras on board also. We should have some fine shots all around in just under 2 minutes. Last October, you remember, we had the inaugural flight of Soyuz, and we're continuing with this series of firsts as the launcher family working out of the French Guiana Space Base, Europe's spaceport, continues to grow. Shot of the fairing there, you see the logos on the outside, LARES and the other satellites, and Vega, the sun beginning to make its appearance here. Big moment for European space. After 1979, Ariane 1, and 1996, Ariane 5, 2012, this year, the year of Vega. The first entirely new launcher to fly from the space base in over a decade, and a lot of emotion across the space base, as you can imagine.
À tous de DDO, attention pour moins 1 minute.
DDO is going to call out the 1-minute mark.
Top. H0 moins 1 minute.
We are into the final 60 seconds before Vega's maiden launch. The VIPs and the invited guests here in Jupiter are beginning to make their way out on the 2 terraces on either side. There's a wonderful view of the launch pad from here. Countdown proceeding smoothly. Excitement here has been high all week. It's another one of those moments right now as all eyes on the computer screens and all ears at the telephones as we approach liftoff. We're going to cut away and let you hear the DDO. She'll call out the final countdown numbers. Enjoy the launch. We'll be back after Vega has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage premier étage, décollage. La trajectoire est normale.
Boy, did she go up in a hurry. Did you see that? Vega lifting off like a streak from the pad here, unlike Ariane 5,
La trajectoire est normale.
which takes her time. The DDO is saying everything is normal up there. 137 tons at liftoff. Ariane 5 weighs over 6 times that much. But these are pictures that are going to go around the world, the maiden voyage. Vega's first 3 stages rising rapidly, and boy, you saw that in 5 minutes. The first stage will separate in about 30
La
seconds.
propulsion du premier étage est normale.
Propulsion is normal. The second stage will separate in about 3.5 minutes. The third stage ignites shortly thereafter, and the third stage separates in about just under 6 minutes. We're doing fine up there. Take a look at the left-hand side of your screen. On the upper left, the cursor crawling up the curve, there are actually 2 lines. There's the optimal trajectory and the real-time trajectory. As long as one is superimposed on the other, we're right where we should be. On the lower left, the 2 lines, A is the altitude, climbing up to 57 kilometers, V velocity, our speed, 174.
Séparation du premier étage.
There's the separation of the first stage.
Allumage du deuxième étage.
Right on time, and the ignition of the second stage. First stage burned perfectly, jettisoned at about 61 kilometers up. The motor called the P80 FW. P80 produced in Colleferro near Rome. We'll have a film on that
La trajectoire est normale.
coming up. Everything is fine on board. The P80, the first stage, has something new. The thrust vector control system is using electromechanical actuation for the first time ever on a launcher's first stage instead of a hydraulic system. The actuator is a bar that controls the first stage nozzle orienting the thrust upon command from the computer, onboard computer, sort of like the steering wheel.
La trajectoire est normale.
The advantages is it's lighter, easier to integrate, and cheaper. A world first for a motor of that size. We're in the second stage burn. Weighs 25 tons, 23 are fuel. Both the Zefiro stages, the third and the second stage, produced by Avio. They're loaded with solid propellant before being shipped here to the spaceport. Not very different than what's done for Ariane 5. Both stages, based on a Zefiro solid propellant motors already developed
Séparation du deuxième
by
étage.
Avio. There's the separation of the second stage. Our speed now 3.8 kilometers per second, as you can see on the left. We are right where we should be. Third stage, 4 meters long. It's Vega's smallest solid propellant motor, but it has the longest burn
Allumage du
time.
troisième étage.
Longest burn time, over 2 minutes. Weighs 12 tons. 10
Le rattrapage est calme.
are fuel. We're approaching the fairing jettison. You'll see the 2 halves of the fairing, there they are, right on time, being separated, revealing to the elements, the satellites. Fairing protects, of course,
Séparation de la coiffe.
the payload from the shocks during Vega's ascent through the atmosphere, and once we leave the Earth's atmosphere, we don't need the fairing anymore. There's LARES. You see the ball with the mirrors right in the middle.
La trajectoire est normale.
The black and blue box on the left is ALMASat, and the other CubeSats around it on the platform.
Acquisition de la télémesure lanceur par la station navale Ariane.
DDO has just called out. We've been picked up by our first downrange tracking station. That's on a boat out in the Atlantic. We'll have a film telling us all about the new facilities, including the new tracking stations that have come to the base because of Vega.
Le pilotage est calme.
See, we're burning the third stage, and on top of the third stage is the AVUM. That's the fourth stage. That's just under the fairing platform there. Altitude 166, speed 6.25 kilometers per second. We're coming upon separation of the third stage. The Vega base designed to handle 4 launches a year.
Le pilotage est calme.
Eventually. The Vega Launch Control Center, which you saw earlier, in the same building that houses the Ariane 5 Control Center. Mission control is provided from the same Jupiter building where we are tonight. That's used for Ariane and Soyuz launches. Everything functioning flawlessly on board Vega as we're approaching third stage separation. and we'll have ignition of
La trajectoire est normale.
the AVM. The trajectory is normal, the speed is normal, the propulsion is normal on this maiden flight.
Séparation du troisième étage.
And there's the separation of the third stage, done its job. There's the AVM,
Premier allumage du quatrième étage.
and there's the first ignition of the AVM. Our speed now 7.7 kilometers. We've almost reached our maximum speed. This is the fourth stage, called the AVM, which means attitude and vernier upper module. And when Davide gets back, he's going to tell us what that means exactly. But basically, a vernier referring to the precision required by the upper stage, because the AVM is designed to deliver different payloads
Tous les paramètres du quatrième étage sont
into
normaux.
different orbits and to perform very fine satellite pointing before separating the satellites. The AVM's main mission begins
Le
at the
pilotage
end
est calme.
of the solid propellant base, which you saw. It starts maneuvering to reach the targeted
trajectoire est normale.
deployment orbit. Everything is fine on board. The DDO calling out repeatedly, trajectory normal, propulsion normal, everything nominal is the word here. The AVM burning, you can see, carrying 626 kilos of propellant in her 4 tanks, powered by a restartable engine. We're going to have several burns on this first flight. We're in the middle of the first one, which will last until almost 9 minutes, almost another 2
Tous les
minutes to go.
paramètres propulsifs sont normaux.
After that, we'll have a coasting phase for some time, which is also called a ballistics phase. Soyuz uses the same sort of procedure. And the second AVM burn, it will come between
Le
plus
pilotage est calme.
48 minutes and plus 52 minutes. And shortly after that, at plus 55 minutes, LARES will be separated. Then we'll have a third AVM burn at about an hour and 9 minutes. And that lasts for about 2 minutes roughly, with CubeSat and ALMASat-1 separation. You can see the nozzles burning off and on the
Le
AVM.
pilotage est calme.
This is her guidance system. She uses 2 clusters of thrusters for roll and attitude control. They'll start to work during the ballistics phase. On board the AVM are all of Vega's avionics, which provide the flight control and the mission management, telemetry, flight termination, power supply, distribution, all of that. The AVM will reach a circular orbit at 1,450
La
kilometers
trajectoire est normale.
to release LARES, then maneuvers to lower the perigee to 350
Le pilotage est
kilometers
calme.
before deploying the other payloads. This does not mean it'll deorbit directly when
Tous
each
les
mission
paramètres du quatrième étage sont normaux.
is over. It'll be transferred into an orbit with a perigee low enough to ensure re-entry, and that's the case today. Coming up on 9 minutes, and that will mark the end of the first AVM burn. And Davide has returned. Davide, how's the ambience down there in the fishbowl?
Wow.
Extinction du
What a
quatrième
day.
étage sur
Well,
commande de guidage.
everybody's still very focused because still not the end of the mission, but
Début de la phase balistique
I'd just
intermédiaire.
like to anticipate it was a great success.
I was struck
Really?
by the fact that she took off and lifted just like a streak.
Absolutely wonderful.
Much great. You're out of breath. You're so excited.
Sorry. I am. It's been 2 years of long work here. Well, 15 months of long work here, and to see this go up so well, I mean, I'm really.
You must be very pleased and
I
proud
am very
and happy.
pleased, and I'm sure from the whole team, everybody works on Vega, starting from the program manager down. I mean, everybody
La
is.
trajectoire est normale.
There he is, Stefano.
There is Stefano Bianchi.
Acquisition de la télémesure lanceur par la station de Santa Maria sur l'île des Açores.
All right, we've been picked up by our next downrange tracking station. That's the island in the Azores belonging to Portugal called Santa Maria. Vega's path is taking her north above the Atlantic, then over Scandinavia. We'll be picked up by a Norwegian station. Russia, then down over China, Korea, Australia, Antarctica, and we have tracking stations on most of those places. You want to give us a recap of what's been happening so far?
Well, yeah. So we'll.
Any surprises that?
No surprises. So it's went through the first stage separation was the most critical,
Fin
went
de la phase
flawlessly.
d'orientation du quatrième
And
étage.
second and third stage, now we're in the burned also nominally.
Début
So
du
now
mode
we have the
barbecue à 2
first
degrés par seconde.
oven burn. We're going through coasting and also fairing separation. Perfect. So I think now the last milestone will be to important one to put the separation of the LARES.
Pas de perturbation, oui.
Last burn, separation of the LARES, and then we can really cheer.
You said that a very critical time was the first stage. You're watching a replay. Look at how she rises right.
Rises forward up. Yeah,
really, that's like an arrow.
Yeah, 1G flies up.
Beautiful. Went right up there. Look at that.
Yeah. 280 tons of thrust, 130 tons of mass.
You mentioned that the P80, the first stage,
yeah,
was a. Oh, here we go with another replay from another camera.
Wow.
Remarkable.
Perfect.
Yes.
Yeah, the first stage separation.
Why was that
is,
critical?
well, it's you know, the first stage is the heaviest of all, and we have to make sure that we have a smooth separation. We have retro rockets, so in very short sequence, very fast sequence, we separate, we activate the retro rockets, push back the atom, and then activate the second stage. So it's went very well.
Tell me, what went through your mind as you saw Vega lift off after all these years of work? You've been on the program for how long? 2 years?
I've been a couple of years in the program, followed all the operations here.
So what went through your mind when you saw her leave finally?
Oh, well, great achievement. I think it's a great achievement for Europe, great achievement for all the people who worked on the project for so long. As was said before, it's a 10-year program. Been through difficult times, as expected. I mean, but I guess this perfect first qualification flight. We're not over, so I don't want to go on saying that again. But up to now, all this, what we've seen up to now is going very well. It's a very good, it's a remarkable end of this first qualification program.
All right, Enrico Saggese, president of ASI, the Italian Space Agency. You'll be hearing from him in a moment. You see our speed is diminishing a little bit. Our top speed was 7.8 kilometers per second, and we're not going to be moving any faster than that. The AVM is the white bit on the left, and the platform with all the satellites on the right. A word on the downrange tracking stations. All of Vega's trajectory has been designed, like Ariane, like all of them, to be followed from the ground. And the launcher is sending back radar and telemetry to the network of stations, and there are several of them. They keep constant watch on the health of her vital systems. The antennas pick up the signal and follow her progress, and then all it's being sent back here to the base on the hill behind us called Gallio, Montagne des Pères. The tracking station network gets ready to go at minus 22 minutes before liftoff. Now all this telemetry that they send down, telemetry basically is what? It's measuring from a distance, I guess. Huh? Is that a reasonably good description of it? Yeah. There are thousands of parameters to measure, all indicators of Vega's health in flight.
Yeah, absolutely. We have, in fact, we had a team of us monitoring in real time the.
We'll be back with more on that, but a word on the tracking stations from Joel Barr, again, the head of the space base, and the DDO today, Amy Sipa.
The coming of Vega to Europe's spaceport brings big changes to the launch complex. In addition to giving it a more international dimension, there will be twice as many missions, from 6 to a dozen each year, with all 3 launchers, Ariane, Soyuz, and Vega, and these will call for a larger workforce. Already, over 200 people have been added to the growing list of technicians and engineers. The payload preparation buildings have been upgraded, and for the flight itself, entirely new facilities for following the launchers have been put in place. It's all part of a chain.
This is where our new means for tracking the launcher come in. When we launch toward an equatorial orbit, we always use the same downrange ground tracking stations that receive the telemetry. Now, no. For each launch, we will use stations spread all over the world, in Korea, Japan, Australia, and New Zealand. Even on a boat, we have a tracking station on a ship in the middle of the Atlantic to receive telemetry from the launcher during its flight.
Setting up the teams who will work these new downrange tracking stations is the job of the Range Operations Manager, or the DDO. The DDO coordinates the operational people during preparation of the launcher and satellites, but also during the positive time chronology following its trajectory with these teams until the end of the mission.
It is a tremendous effort which called for a certain amount of back and forth, and also many visits to the sites to be able to put in place the specific teams who will be able to receive the launcher telemetry signals. It is a wonderful challenge, and I think the investment on the part of all the operational people for the setting up of this downrange tracking station network is a source of pride for all of them. And also for me as the DDO for this first qualification flight for the new Vega launcher.
Close to 17 minutes in Vega's maiden voyage. She's doing fine. On this qualification flight, Mr. De Pasquale, we'll be hearing from him. He's the head of ELV. We'll be hearing from him in just a moment. Qualification launch validates the new downrange stations that you saw. The mission, remember, qualifying the overall system, which means the vehicle, the ground stations, the separation systems, and everything, right?
Right, yeah. So in fact, what we call that the launch system. Launch system includes definitely the launcher, all the ground segments, so what you have seen, the gantry, the building that is used to integrate the rocket, and then to host all of the integration of the payload, and then all the retraction systems, and then overall all the operations with the station, as you mentioned. So launch system is the overall.
And all this data comes in and is stored somewhere, and you go over it after the launch for
oh,
weeks?
Yeah, I mean, after this qualification flight, we're going to have to review flight data, the behavioral launcher, all the ground systems. So we're going to have to make sure that we have achieved all our qualification objectives.
So more work for you. When we come back, we'll talk about the small satellite market. But first, Yannick Descata, president of CNES.
France has been heavily involved in the Vega program. It has funded around about 25% of the program. The CNES Launcher Directorate has assumed contracting authority through delegation from ESA for the first stage of the launcher, P80. That is a solid propulsion stage, which is highly innovative. It makes it possible to reduce costs and to boost performance. The CNES Launcher Directorate has also taken part in the work of the integrated project team, providing to the team both onboard and ground technical support. Let me express my sincere and warm thanks and congratulations to all of the teams involved, from ESA, from the Italian Space Agency, CNES, the French Space Agency, Arianespace, and all of the industries who've been working so hard for so many years to give Europe this major launcher that it so needs and of which we can all be so proud.
Vega will have a big future in the small satellite market. That deserves a word. In the late 90s, space agencies pretty much worldwide started developing small satellites. And especially in the years following the fall of the Soviet Union, large numbers of decommissioned ballistic missiles became available for refurbishment into low-cost small satellite launchers. You might remember the names Rocket or Dnieper. Jean-Yves Le Gall talked about that briefly in his opening words. For years, availability of these plentiful and affordable vehicles prevented development of a competitive launch solution like Vega on this part of the market. But the era of refitting old missiles had begun to end because the stockpiles of these available missiles began to dwindle for several reasons. No new hardware had been produced in the last 20 years. The best preserved stage has all been launched. And keeping the aging hardware flight-worthy grows harder and more expensive, of course. It has been noted, as a matter of fact, that the lifetime of the Rocket, which is also called the SS-19 missile, was 33 years. And if the last ones were produced in 1984, that means they should be phased out in about 5 years from now. So Vega coming on the market at the right time. There are other competitors, but market studies are showing that an estimated 5 to 7 small satellites should be available every year until 2015, all heavier than 250 kilos, therefore compatible with Vega. Neither Ariane 5 nor a Soyuz really adapted for this type of small payloads. Their markets are different also. Do you agree with all those figures?
I agree, and actually to confirm what you're saying, in fact,
Tous les paramètres à bord sont normaux.
we just had two first commercial satellite contracts signed for Sentinel 2 and 3.
Or Sentinel. More of the mission in a moment, but for now, the latest news from Europe's space sector. Many new contracts were signed, as Davide said.
Another successful mission from Europe's spaceport on December the 16th as the second Soyuz flew flawlessly. The Russian vehicle carried a payload of military passengers, Pléiade and ELISA for France and SSOT for Chile. Arianespace is responsible for the next Pléiade mission, which will use another Soyuz and is due to fly this autumn.
The third ATV, or automated transfer vehicle, bears the name of the father of Italy's space effort, Eduardo Amaldi. An Ariane 5 will take the cargo vessel toward the International Space Station on March 9th, bringing much-needed supplies, food and water to the space station crew. The ATV-3 is the heaviest passenger ever lifted by Europe, over 20 tons.
On February the 2nd, Didier Febvre for the European Space Agency and Jean-Yves Le Gall of Arianespace signed the agreement for the launch of the next group of satellites in the Galileo constellation. Galileo is Europe's global positioning system, which will have, when completed, a network of 30 satellites. The 26 yet to be lifted would all be launched by Ariane 5 and Soyuz.
In another collaboration between ESA and Arianespace, METOP B will be launched next May 23rd on a Soyuz from the Baikonur Cosmodrome in Kazakhstan. METOP B will replace METOP A and is part of a series of 11 weather satellites in polar orbit. Their mission is weather forecasting and collecting data on global climate.
The third MSG satellite, developed by ESA and operated by EUMETSAT, will lift off from Europe's spaceport in French Guiana next June on board an Ariane 5. This project, too, is a partnership between ESA and Arianespace, one that goes back to 1977 when Meteosat-1 was launched on an Ariane 4.
And talking about partnerships, who does what in the Vega program? Many people involved, of course. ESA, the European Space Agency, responsible for implementation of the program and its technical and financial management. ASI, the Italian Space Agency, whom you're going to hear from in just a minute, provides half the funding, roughly, and has a big management role also. CNES, the French Space Agency, led the project team for the first stage motor development and was involved as in many of the tests also here at the base. Arianespace, as with Ariane and Soyuz, holds exclusive rights to market the vehicle. And once Vega is qualified, and she's on her way to being qualified tonight, operating it will be under Arianespace responsibility. ELV, the industrial prime contractor. Avio, the primary industrial partner. And finally, Vitrocisset, the prime contractor for the ground segment. You wanted to say something on the Italians, your home country.
Oh yeah, well, Vega is definitely a European project, but it was started as an Italian project, and so I'd say it's still led. 60% of the project is Italian, and so it's a big day for Italy for sure. And considering also, as his president said earlier, I mean, Italy was the third country, 64 to put a satellite in space.
With more on the Italian Space Agency role, we go now to their Director General, Enrico Saggese.
Italy has been the third country in the world to launch a satellite. The first launch was from Wallops Island. The following ones were from Malindi in Kenya. The initial date was 1964. Since then, 48 years have passed till the adventure of Vega starting. This first launch of Vega is the completion of a dream of initial professors like Luigi Broglio and Carlo Bongiorno, who then spent their life creating the cultural capability within the university and then associating industry to their dream. So this dream has been completed. University, the Italian Space Agency, the industry, Avio, are now all together in this new capability. But this capability is not only Italian, it's the capability of Europe. It's the possibility of Europe to access space in an efficient and costly effective manner in low Earth orbit. What is really important then is that the Italian dream has become a European solution, a European result.
And some of those results already, there are 5 more Vegas ordered under the next program called VERTA, V-E-R-T-A, which means, I believe, Vega Research and Technology Accompaniment. I got that right? Exactly. Yeah. Currently in production, these 5. Arianespace will soon launch production for its own commercial flights. The VERTA program was designed to support the initial operations of the Vega system. That was approved by ESA in 2005, and the payloads have already been designated. Everything on board is perfect, the DDO says. 4 of the 5 flights already have their payloads, a series of microsatellites, of course, small ones, planned to fly between 2013 and 2015. Now tell us about those. There's an Earth observation satellite, there's LISA. You worked on the LISA.
Yeah, I worked on LISA also. A lot of very exciting missions coming up from VERTA. Science, ALUS and LISA are 2 very challenging scientific missions.
ALUS is the Earth observations.
Earth observation, yeah.
That's on VERTA 2?
Exactly.
And then
yeah, 3, LISA Pathfinder.
And what's that? That's like Herschel Planck launched by your...
Well, LISA is like as a Pathfinder for the LISA mission, which is going to be a gravity wave detector. So it's an incredible mission jointly developed by ESA and NASA. So it's a
big one.
Big one.
And then the ones that were signed, the commercial ones, are the 2 Sentinels for the defense
yeah, absolutely.
program. That's all ahead. They're talking about 2 Vega launches a year in the future. This could double to meet customer demand. Yeah.
Oh, I guess it will eventually. I heard earlier Arianespace chairman saying that they're looking for a market up to 5 launches a year. So that's I guess there will be definitely space.
We're going to leave French Guiana for Italy again now to take you to Colleferro for a look at how Vega's stages were produced. Colleferro is a small town in the middle of Italy, not far from Rome. It's where most of the work was done to prepare Vega for its qualification launch. Because of the dry heat, in 1912 it was selected as a suitable place to manufacture explosives. This ended years ago, and the site was taken over by Avio for its aerospace work. Avio is prime contractor for Vega's P-80 first-stage engine. ELV, a joint venture between Avio and the Italian Space Agency, was created to be Vega's prime contractor.
We are in Colleferro, where we have the Avio plant for preparation of the stage and the ALV laboratory for tests. After several years of work to development the qualification of the subsystem of the Vega launcher, this activity is completed the last years. The conclusion of this activity for us is a very important milestone because conclude a long phase of the preparation of these components for Vega.
It also means that Italy is now one of half a dozen countries in the world able to produce a launcher. 65% of Vega is made at Colleferro. During its development, acoustic tests were carried out here, simulating conditions at liftoff. Some tests, which included ignition of the motor for several seconds, involved 42 microphones. Tests completed at Colleferro were an important step toward ensuring a successful flight for Vega and its payload.
You've probably noticed during the filmed portions of the broadcast, you can keep track of Vega's trajectory in real time. That's by watching the animation on the left under the statistics in the blue band. We mentioned again, this is a qualification flight, not a commercial mission. There's still a lot to say about the qualification flight. The objectives to qualify tonight for the launcher include, you can imagine, liftoff, ignition, performance, flight control, thrust control, separation of the stages, fairing separation, the AVUM's performance and its restart capability, very important, payload release maneuvers, we're not there yet, and accuracy, and finally the AVUM passivization at the mission's end, that's when they drain the fuel, and the deorbiting phase. Now, to get to where we are today, many tests were performed progressively from component to system. And this is what qualifying a new launcher entails. Now, you were present at all those, most of those tests.
Yeah, we had a 3 months intense launch campaign here. To prepare the launch campaign, we had over a year of testing here in French Guiana, where we rehearsed, we simulated. We had a mock-up of the launcher.
On the pad.
On the pad, we had that was called, we called that phase a combined test phase. So we went through a whole launch campaign, but with a representative mock-up. It's actually almost, looked like a real launcher from outside.
Wasn't filled or anything?
Was filled with simulant. It wasn't charged actually propellant, but it was same mass, same dimension. From the outside, it looked basically like the real one, and also had a lot of electrical systems in there. And then we used that to go step by step and verify all the steps of the campaign, all the verification process, all the tools, the control bench, all these automatic sequences you had seen, and all this was went through a long preparation phase.
Vega and Ariane are sisters, much in common. To find out more, we return to Stefano Bianchi, whom you saw earlier. Vega would not exist without Ariane. It uses much of the technology already developed for Ariane 5. The third stages, for example, the Zefiro stages, are built in the same place and by the same teams as the Ariane 5 boosters.
Mostly of the industrialists which are working on Ariane 5 produce the same pieces also for Vega. There are also some equipment which are the same between Ariane 5 and Vega, so we have the same inertial reference platform, inertial reference system. All the equipment linked to telemeasuring are the same as on Ariane 5.
This tech transfer goes the other way too. New technology developed for Vega will be later applied to upgrading Ariane. This is particularly true of Vega's first stage, called the P80. It has a double purpose.
On one side, to be the first stage of Vega, and on the other side, to develop new technology which could have been used then later for an improvement of Ariane 5 boosters. So this was the initial idea. That's the reason why it is called the P80 Solid Rocket Propulsion Demonstrator, because the idea was to use then composite case technologies, actuator technology, nozzle material, developed through the P80 also on Ariane 5.
Each of Vega's engines has had 2 test firings on the ground. But after the qualification flight, its teams in French Guiana and around the world will know a lot more about the launcher, its systems, and their behavior.
The Italians wrote the first essays on solid propulsion, something they've been working with since the 16th century. I think Marco Polo brought back the notes from China on the fireworks. And they also made the solid boosters, as you heard, for Ariane 3, 4, and 5. Remember, if you're looking on the left, we are at altitude of 1,200 kilometers. Separation LARES due at 1,450 kilometers, so we're approaching. You see our speed diminishing. We were at 7.8 kilometers, so we are dropping our speeds, quite normal. Davide, you were part of Vega's integrated project team. That's the Vega High Command. Tell us all about that.
Right, that's the, it's called integrated project team because, well, it's ESA, and when incorporating, we had integrated in the ESA team, we had CNES personnel and ASI personnel, and that was also a first, also in respect to other standard ESA projects, and it was worked very well. And we really worked with different expertises, and we managed to.
And they covered all the tests and all the initial procedures and things.
Yeah.
Right. If you're as old as I am, you might remember the first 4 flights of Ariane 1 in 1979, 1980, and 1981, and the first 2 flights of Ariane 5 in 1996 and 97 were also conducted on behalf of ESA, like tonight, before the launchers were handed over to Arianespace for operation. That's the same process. Like Ariane 5, part of Vega is produced right here in French Guiana. A look now at this local firm that plays a major role in Europe's space feats.
In In 1976, CNES reported to ESA that the new Ariane launcher, then under development, could increase its performance by adding strap-on solid boosters. Later, for Ariane 5, ESA financed construction of the French Guiana propellant plant, today run by the Regulus company.
Since the start, in 1991, Regulus has manufactured over 300 segments for development qualification on the Ariane 5 flights. There have also been 4 PADs for Vega, including the one for today's launch. In terms of propellant, that makes more than 33,000 tons that have been manufactured.
Regulus counts 46 buildings spread out over 300 hectares. Each is situated well apart from the others for obvious security reasons.
It is worth mentioning the 2 mixers. They are unique with a 12-ton capacity each. We use them to make the propellant for Ariane 5 and Vega. Then there are the casting buildings. Each has 2 casting shafts, giving us a total of 4. 2 are historic. They have been in operation since the plant began its activity. A third, introduced for Vega on the PAD, which has been operational since 2004, has since been qualified for Ariane 5 as well. The fourth is more recent, used by Regulus since June 2011. Regulus has a maximum capacity in these facilities of 7 to 8 Ariane 5 and 3 to 4 Vega launches.
The Regulus manufacturing cycle has 2 parts. First, preparation of the structures for Ariane 5 and Vega, which are then sent by ship from Europe. This is completed by placing them in a shaft in a vacuum where they wait for their propellants to be produced.
The propellant is manufactured by dispersing in a polymer matrix a large quantity of powder, including a combustion agent and a combustible. The resulting paste is then poured into the casting shafts. After a reticulation phase, the propellant will have acquired its definitive form and texture.
The filled structures are then sent to be stored. 4 weeks later, after the propellants have settled, they are checked. These checks are carried out with an X-ray generator, the most powerful one in the world, in order to guarantee their quality.
Ultimately, the structures are delivered to Europropulsion, which integrates the different segments. These segments then become a stage.
The production chain for the solid boosted propellants used by Europe's space sector is an industry that is basically a French Guiana affair. The company's place in the social fabric here is quite strong.
It's true that, to begin with, most of our employees were seconded by the parent companies to import the necessary skills to French Guiana. Today, however, we tend to hire people on local contracts. 70% of our 95 employees actually live here in French Guiana. We also use local industries for the everyday maintenance of our facilities. There are also the external logistics, in other words, the port employees, and the people who transport the raw materials and structures to the factory.
Thanks to experience gained after more than 20 years in the space business, Regulus is ready to meet the challenges of future European launchers.
While you were watching the film, we were picked up by our next downrange tracking station in Jeju. I think I'm pronouncing it correctly, in South Korea. Remember, Vega went up over Scandinavia. She's coming down now towards Antarctica. You had a word on the production of the first stage.
Yeah, like as for Ariane, we have first stage PAD is actually filled propellant, solid propellant, prepared here in French Guiana, and the stage, so the first stage is actually finally assembled and prepared here in Guyana, while we have the other 2 stages, the Zephyr 23, Zephyr 9, they come in from Europe already filled, prepared,
already filled,
tested, ready to go.
So it's about half and half, European production and Guyanese production.
Yeah.
This first qualification flight costing roughly, they say at ESA, 40 million euros. The cost should decrease as launch campaigns get shorter, of course, and serial production kicks in, reducing production costs. Vega development overall, over 700 million euros is the figure we get, funded through ESA contributions from its member states. Another 76 million euros coming in directly from industrial investment. by Avio in particular, in development of the first stage of the P-80. Vega is the newest member of the Ariane family. Over to Louis Laurent now, Arianespace's Director of Programs, who will fill us in on the company's role.
As you know, this launch today was led by the European Space Agency, which managed the development activity as it does for all European space launch systems. However, since the early phases of the program, Arianespace has been heavily involved. We have contributed as much as possible of our more than 30 years experience of European launch system exploitation. For the last part of the launch campaign, we have been heavily involved in the operations. Today, for instance, inside the Launch Control Center, we have had an Arianespace specialist team monitoring the chronology. They performed the same type of activities as they do for an Ariane 5 launch. It is also worth noting that the ground system which has been used in the operations today are partly shared with Ariane 5 and partly with Soyuz. This is actually a win-win approach for ESA and Arianespace. ESA benefits from our experienced team and infrastructure. On our side, we learn how to operate the system and prepare our future activity. Following the analysis of the chronology and flight data, the qualification of the system will be pronounced by ESA, and then the system will be handed over to Arianespace. From that point onwards, we will then be in charge of the exploitation activities, performing for Vega what we do today for Ariane and more recently for Soyuz. Commercialization of launch services, procurement of launchers, mission integration, and operations. The first launch in this configuration is expected to take place in roughly 1 year, depending on the result of the flight. Vega will serve a specific niche on a growing market, mainly Earth observation satellite and small scientific missions. According to our projections, we expect there to be 2 to 4 missions per year, and our operational system has definitively the capacity to cope with this launch rate.
Everything fine on board of Vega now. Davide, take us back to the launch campaign for about a minute. You were there during the whole time. What do you remember most? Any milestones that you're going to write down in your diary?
Oh, well, definitely actually in the combined test phase, the preparation for the campaign, I would say the first time we integrated the full launcher on the pad, first time we retracted the gantry, and we had the launcher there standing. That was amazing, and also I have to say the test went very well that time. We verified a number of important things like capability of the launch to resist the effect of the wind and inertial platform, that we were capable of aligning it, and all the thermal systems. So it was a very, very successful test, but also very, very important milestone to remember.
You said combined phase. That comes later on in the.
Yeah, the combined. We call it combined test because we were putting together the ground segment and the launcher the first time, and we're verifying all the interfaces, also the way we operate them together. That's what they're called, combined tests. They were a preparation, in fact, of the launch campaign.
Okay, our altitude, you can see 1,414 kilometers. Our speed, 6.6 kilometers per second. Just to continue with our discussion of qualification, the vehicle, Davide didn't go into this, but it's worth to mention, the vehicle not the only system being qualified for today's missions, the ground systems as well, but we'll get back to that. Our next interviews take us back to the launch campaign with Davide. 2 key players will tell us about what's gone on since late last year when it started.
On November the 7th, the P-80, Vega's first stage, was transferred from the booster integration building to the launch zone. Here it was joined to its launch table and mobile gantry. The interstage between first and second stages was integrated, then the 2 Zefiro stages, Vega's second and third stages, and finally the fourth, called the AVM, was mated on top.
For the first time we have directly ESA as responsible for this phase. It's the end of the launch process started very long ago with all the different development activities that are converging into this campaign. This is basically the main moment to arrive to give to the future operator a launch system which is qualified. Launch system meaning therefore not only the launcher. Often people think only about the launcher, but here we are developing something which is more a system, which is also all the ground segment, including the facilities where the launcher is integrated and tested before launch.
Satellite teams then placed the mission's 9 passengers inside the fairing. in everyone's mind was the success of this first qualification flight, which will give the green light for Vega's next 5 missions.
L'organisation d'une campagne Vega est assez proche de...
The organization of a Vega campaign is very similar to an Ariane 5 campaign, with the same 3 aspects involved: technical, quality, and operational. Of course, the European Space Agency has been heavily involved in all of the qualification for this first campaign. We are getting ready with this for the future because as of the next Vega campaign in the Verta phase, we will be in charge of all the operational activities. We will be the technical authority once the launcher has been handed over to us by ELV, our supplier. We will thus be fully responsible for the combined operations planned with the satellite.
All the data concerning this inaugural flight will allow the teams at the space base to improve Europe's new launcher and ensure her a long commercial life.
Just to continue with the discussion of qualification, the vehicle, not the only system. 2 minutes left in the upper stage burn, I think she said. The ground systems and the launch procedures will be qualified simultaneously, including payload processing and integration, launcher readiness control checks, all these things that Davide was mentioning. A readiness check of the launch base, that's what you were talking about, and all the support means necessary during the flight. Now that includes weather forecasting, downlinks with the telemetry, tracking stations, flight termination, etc. Now, the commercial life is about to start. The small satellite market is growing, as we mentioned. ESA estimates that between 7 single payload launches could have been performed by Vega in the last 2 years, if Vega had been ready, including 3 for ESA, 1 for ASI, as well as 2 or 3 multiple payload launches, like tonight. And as Davide mentioned, the first commercial contract for Vega was signed last December for the 2 Sentinel flights, signed by ESA and Arianespace. You can see that the composite is being oriented, and that's readying for the separation of LARES, yeah? Because she's going to be separated in about 7 minutes, going, of course, in one direction, and then she'll be reoriented again for the other payloads to, number 1, avoid collision, and number 2, put them in their proper place. If you're looking at the altitude again, 1447, we need 1450 to be up near separation. This is the end of the orientation phase, and again she's using her thrusters to
Deuxième allumage du 4e étage.
There we have the second. That's also a good thing to have happen. You see the nozzle popping on. The second burn, which will last I think about 2 minutes.
You were mentioning the orientation. We have 2 propulsion systems on the AVOM, so we have the main engine now that's
Tous les paramètres propulsifs du 4e étage sont normaux.
And for the main propulsion, then we have the RACS system, it's called. It's the attitude control, and that is very important for the final position of the satellite.
RACS, if you're familiar with Ariane 5, it's called SCAR. It's just turned around. This is what they call the space ballet, orbiting, repositioning the orbiter. To get there, to separate LARES, we need the second AVOM burn, and we just had it, so we're doing fine. Looking down into mission control now, the nerve center of the space base. Coming up on the end of the first stage burn. LARES is a scientific satellite. A look now at Vega's first passenger.
It will be crowded under the fairing for Vega's inaugural launch. She'll be carrying 9 passengers. The primary payload is LARES, which will study the Lentz-Thirring effect, or distortion caused by the rotation of a body in space, an idea first proposed by Einstein in 1915. As the Earth rotates, it drags anything nearby with it, causing a shift in the orbits of satellites close to Earth. This was first calculated by 2 Austrian physicists, Josef Lentz and Hans Thirring, in 1918. LARES might look like something you'd find on the ceiling of a nightclub, but it's the latest experiment in this branch of advanced physics.
The satellite system looks like a disco ball because it is embedded with very special mirrors that have the properties to reflect back the laser beam shot by a ground station. So by measuring with very high accuracy the distance between the Earth and the satellites, we have the capability to measure this land steering effect.
It has another purpose as well, which is to understand precisely what is going on inside the fairing during Vega's first qualification flight.
On board of the LARES systems, we have boxes, avionic boxes and sensors that will acquire very important data from the environmental load generated by the launch vehicle. And this one confirmed will be considered for the next payloads that will be embarked on the launch vehicle.
Understanding the conditions of Vega's payloads is key for the launcher's promising commercial life.
LARES means Laser Relativity Satellite. Weighs, as we said, 400 kilos, 92 retro reflectors or mirrors. It'll be released into its circular orbit. And to complement as these two previous satellites, which were called LAGEOS, I think, LAGEOS 1 and 2.
Right, yeah.
Which were also laser satellites launched in 1976 and 1992. LARES is, however, a completely passive satellite. It's made to reflect laser signals, so it will not send any signals to Earth after its separation. This is unusual. Confirmation of its separation is acquired via data sent in real time by Vega, by the launcher. Now, you mentioned the launcher campaign was based on a standard plan, but then you had to adapt, or you had to change.
Yeah, let's say what we have done in the qualification campaign is we based the standard, we based the whole campaign on a standard plan, which is the one we will be following for the commercial flights, and then there was a lot of additional objectives which will entail a bit the overall qualification of the overall launch system in terms also of verifying all the margins and verify that also in the future we have covered the design.
So these are things that you expect when you're going into a qualification
Absolutely,
campaign,
yeah.
I guess.
That one it was definitely longer than what we expected to be for the commercial flights.
That seems to have paid off.
Acquisition de la télémesure lanceur
From Perth, I think she's going to say. Right, we've been picked up by our next to last downrange tracking station down there in Perth. The Vega project, Davide, actually 3 projects, I am told. Development of the launcher to the program to demonstrate the P-80 first stage, and development of the ground segment. Is that right?
Exactly, yeah. So we had overall the responsible for the overall launcher was CLV, the prime, but ESA, the ESA project, the IPT project, but particularly for the P-80, it was the management and the development was delegated to CNES. That was because taken off from the Ariane development. I mean, the P-80 is using the same facilities, Europropulsion we have seen before. They're using the very much the same process and the same people are involved, so that was a logical choice. And the ground segment, as you mentioned, was also a kind of ran for a while as a separate project, always. And then when we arrived in the preparation for the campaign, we started verifying the overall. That's why it was called.
Is that part of the combined?
Exactly. That was the meaning of the combined test when we started to bring together the whole.
Okay, so they start out with the 3 different entities, and then once they get
obviously there's always a Korean approach from the beginning to make sure that everything, the interfaces are correct.
And all that takes how long?
Well, I think we started 2003 with the project, so it took 8-9 years.
8-9 years until the maiden voyage of Vega. She's due to separate her first passenger in just about a minute, less than a minute, actually. Again, this is one of those moments of high concentration for everybody here. Tonight represents, as Davide just said, months, years of work. For some of the people here and around the world at the various stations. The mood here in Jupiter is, I would say, very focused. That's the mood that you found
very focused
down in the fishbowl. All eyes again on their figures.
Séparation de la charge utile principale LARES.
Now, what do you know? There's the first good news. Separation of LARES.
Very well.
There she goes, beginning life. Some applause rippling through.
And here, this is the applause because actually this is actually the end of the launch nominal mission, successful mission.
The qualification.
Say it's a successful qualification for Vega.
because once the qualification mission includes separation of the first.
Yeah, in fact, we have other, we have multiple payloads on this first qualification flight, but they will be separated by the LARES platform itself. So now, basically, we have separated the LARES and the other satellites from the launcher. So now that's the end of the.
So the whole platform is
now the whole platform separated. Now there will be, we separated the LARES and the other payloads are separated. So.
I see. Okay. You see on the top of the platform is the blue box. That's ALMASat, to be released last. And side by side are the small blue boxes, are the CubeSats.
Now we have the.
So the first passenger, LARES, has been separated on time and on target. We had a ripple of applause coming through Jupiter here. Next up will be CubeSats and ALMASat. ALMASat separated in about 15 minutes at 1 hour and 10 minutes roughly. ALMASat, also called Alma Mater satellite, 30 centimeter cube. On this first mission, her main objective will be to test a low-cost and multi-purpose bus, or platform as they call it, in preparation for future launches. Now again, the separation of ALMASat and the CubeSats will be confirmed by the data sent down by the launcher, because the satellites. Why is that? That's not often the case.
Well, we have LARES itself has dual function. In fact, we had all the telemetry system for the satellites, but also a lot of the monitoring of the launcher flight of all the data coming up from the flight or on LARES.
Back with more in a minute. I have to cut you off because we're going to go to a film about the ALMASat project.
Faculty, staff, and students at the University of Bologna's Engineering School were involved in design and assembly of ALMASat-1, or Alma Mater satellite, and they will also handle spacecraft operations in orbit. ALMASat-1 is an Italian space agency educational microsatellite. A technological demonstrator for future missions, it is the first of a fleet to come.
We are trying to validate the possibility to applicate terrestrial technologies such as solar cells, optical systems, actuators, and other instruments derived from terrestrial application to be employed for space application. Thanks to this result, we can demonstrate that the mission can reduce the cost, maintaining the same results and validity of those results. And we are gonna readapt them for future mission that will follow the ALMASat-1 mission.
The project, begun in 2003, will offer the scientific community a low-cost, reliable platform that can be used for many space experiments, including the next ALMASat, number 2, to be called ALMASat-EO, which will be used for Earth observation. Testing this platform is the main goal of its first mission on the Vega qualification flight.
If you just joined us, you missed the first part of the action. LARES has been successfully separated by Vega, but don't worry, you have 8 more satellites which you can watch being sent into orbit remaining, including ALMASat in 3 minutes, along with the CubeSats. We've been talking about the importance of the universities in the CubeSat and ALMASat projects, like the University of Bologna with ALMASat, 7 European colleges that worked on the CubeSats. There's one university we want to mention that has played a big part in Italy's space adventures since the beginning. That's the University of Rome, La Sapienza. The first Centro Ricerche Aerospaziale, or CRA, was created there in 1959. That's the year after NASA was born. And 3 years later, the university signed an agreement with NASA, which aimed at joint research efforts. And this was called, guess what? San Marco, just like the platform and just like the satellite. And the pact brought Americans in to train an Italian team for launch operations. And as you saw in the film at the top of the broadcast, they started with suborbital launches from Wallops Island under NASA supervision, and then later from the Italian site at the San Marco platform off the coast of Kenya. The University of Rome also behind the 1977 effort to improve the Scout launcher. So the Italians, led by the University of Rome, and today with CubeSats and ALMASats, bringing in the educational sector which is so important. And we have an ESA continuing with the education projects. We're going to have a film coming up on the importance of ESA's educational programs. Next up is CubeSat and ALMASat separation. We got a film on the final passengers now, the groups of CubeSat, which are going to be separated in about 12 minutes. A film now on how they were put together.
The 7 CubeSats were developed by universities in Spain, France, Italy, Romania, Hungary, and Poland, and primarily by the students themselves. The universities were free to choose the goals of their missions, which offered students hands-on experience in satellite design, integration, and operation.
These small satellites, 10 by 10 by 10 centimeters, 1 kilogram mass, can be actually built with a limited amount of resources. So they are very popular in the community of the universities. They have actually become an important educational tool.
Though they are small satellites, they represented a big challenge. Students developed CubeSats from scratch as a complement to their engineering studies. They defined the mission, planned the design, and integrated their spacecraft right up to launch.
But most of the work has been done by university students. And some of these students actually are also very proud because they have become the first team able to build a satellite to be flown from their countries. So we are going to have PWSat from Poland, we are going to have MASAT from Hungary, and Goliath from Romania. So all these 3 countries are going to have their own satellite, their own first satellite launched with the Vega maiden flight.
The objective of this qualifying flight is to understand the conditions endured by the satellites under Vega's fairing. This first mission is a full one, but holds the promise of more to come from the successors of these first payloads, which all have specific goals in testing ideas for new technologies, software, or equipment on orbit.
Acquisition of the signal excuse me, from the 7 CubeSats is expected between 30 minutes and 2 hours after their separation. CubeSat team getting together for some huddling there. Most are using ground stations at their own home universities. This is interesting. Qualification flight offering an opportunity for the payloads of different natures, as you see, scientific or educational, which is why ESA decided to offer a free launch opportunity to a number of these student-built satellites. In addition, it of course demonstrates the suitability of Vega to launch CubeSat-class satellites in the future, very small ones.
Il reste moins de 5 minutes avant le réallumage à Voom.
Didio has just said we have 5 minutes left in this second ballistics phase before the second ignition of the AVUM. The separation of ALMASat and the CubeSats will be again, as with LARES, confirmed by the data sent down by the launcher, but these data will only confirm the correct orbit parameters, not that separation has occurred. And we're only going to know this later upon reception of the signal. Now, for this mission, reaching the correct orbit is the success criterion for ESA, and the Vega launcher will be qualified. ALMASat, the first educational microsat entirely designed, manufactured, and assembled at the University of Bologna, and many of the subsystems also used commercially available technologies, what they call COTS, commercial off-the-shelf technologies. In the film there, you saw that for the CubeSats, they're not very expensive to produce. You might not know ESA has an educational projects department. We go now to Roger Walker, who directs the agency's educational programs.
ESA has a mandate to motivate young people to embark on careers in science. Its educational programs include student satellite projects like ALMASat and CubeSat. These projects give students a rare chance to participate in real, not academic, space work and are highly valued by the educational institutions.
We have good feedbacks from not only the universities who appreciate the experience that the students are getting, which is very complementary to the academic studies they're doing, because here with development of satellites they really get hands-on with the engineering, and that really complements the education programs. But also we've seen, following the students when they enter their careers in the space industry, that this has really been a benefit to them, and it's led to a strong workforce.
The CubeSats on board the first Vega mission are one of ESA's top educational projects. They confronted students with a particular puzzle: how to create an experiment for a tiny box. For these students, the chance to participate in satellite projects like these represents a dream come true.
Of course, the students have never been exposed to this opportunity before, to actually develop and have it launched into space by ESA, and then of course they get to operate it in orbit. So this is a once-in-a-lifetime opportunity for them.
The goal is to have students learn the lessons from nanosatellites like CubeSat and apply them on later, larger payloads. There's Roger Walker. Less than 2 minutes in the ballistics phase, in the AVUM. Just a word on the CubeSats, a rundown. E-Star is built by the Polytechnics Institute of Turin, hence Italian. Goliath from the University of Bucharest will perform Earth imaging and conduct measurements of radiation and micrometeoroids in low Earth orbit. That's Romania's first satellite, as was mentioned. ALMASat-1, or Magyar satellite, from Budapest University of Technology and Economics, is Hungary's first satellite, and Poland's first satellite, PWSat-1, developed by Warsaw University of Technology. It will deploy a solar sail, very popular research area these days, a solar sail to accelerate the removal of picosats, or nanosats, or microsats, at the end of their missions. There is Robusta, which stands for Radiation on Bipolar for University Satellite Test Application, from the University of Montpellier, French one. Robusta will study the effect of radiation on electronic components. Two more, UniCubeSat GG from the University of Roma that we talked about. Will deploy 2 booms to demonstrate gravity gradient stabilization on a nanosat, and each boom will carry a solar panel for electric power. Finally, Satcobeo, University of Vigo, Spanish, will also test a solar panel deployment system. It's the first regional satellite for Galicia. Cool, congratulations to all of those teams. They're all using the small CubeSat standard, 10 centimeters by 10 by 10 and weighing 1 kilo. Larger ones have seen the light of day. It's a concept that originated in 1999 in the US at California Polytechnic, Cal Poly, and at Stanford University, as a hands-on educational program for students. There's our third AVUM boom ignition, burn ignition, I should say, coming right on time. We have a short burn, and shortly thereafter, we should be having the separation of our satellites. Cal Poly and Stanford developed the CubeSats as an educational, hands-on educational program for their students so they could develop and launch their own satellites. And since then, it's become very popular, with a large number of organizations, universities, industry, government, have developed and launched their own CubeSats, and their utility has expanded. You can see tonight. It's an open standard that has been adopted by many universities in over 20 countries. A total of over 100 CubeSats have been launched since 2003. For 10 years, they say, the US and Japan have been quite active with CubeSats, educational nanosat or picosat projects, call them what you will. But you can't really say the same for Europe. DDO has just called out, we've been picked up our final downrange tracking station that's in Antarctica at McMurdo. You can't really say the same for Europe, largely due to the limited launch opportunities available to put these products in orbit, and we mentioned that before. Vega's qualification flight today was thus seen as a good opportunity to start catching up. Future Vega flights may offer a good way to provide flight opportunities to students who might become our next generation of space engineers. So a lot riding on the maiden voyage tonight. CubeSats are the first CubeSats to be launched on a European launcher, of course. And from Romania, Hungary, and Poland are the first satellites ever launched by those countries. That was mentioned So ESA allowing first access to space for a new ESA member state, which is Romania, and a soon-to-be member state, which is Poland, and an ESA cooperating state, which is Hungary. The CubeSats from France, Spain, and Italy are the first CubeSats.
Nouvelle extinction du
of these
4e
countries.
étage.
End of the final upper stage burn. And you see Jean-Jacques Dordain embracing Antonio Fabrizi and the other top leaders of the program, and Stefano Bianchi, Jean-Yves Le Gall. We haven't heard confirmation of separation of the other payloads, but it comes with the extinction of the third stage burn. So apparently, you see Antonio Fabrizi, hugs all around, congratulations.
Début de la séquence de séparation attendue des charges utiles secondaires CubeSat et ALMASat qui sera confirmée par ESA-IPT dès que les données de la télémesure de la charge utile LARES seront disponibles.
So the DDO has said we will get the confirmation of the separation coming up, but this is what has happened up there. ALMASat, the blue box there, coming last. The first satellites, the first CubeSats going. There are 3 CubeSats. 2 of them have 3 satellites. Boom, boom, boom. The first 2 have gone, 10 seconds interval, and the third CubeSat containing 1 satellite due to go next. There it is. So you can see the applause continuing here. The good news, Vega successfully separated all her passengers, her final passengers. You're leaving us again? Davide has to go back into the fishbowl. Yeah? You're taking off? You're
taking off.
Okay, well, thanks for being with us. It was very enjoyable and very informative,
Thanks
and
to you,
congratulations
Josh.
to you.
It was an amazing qualification flight.
All right. Don't get lost on the way down.
All right.
Cheers. All right, David is going down to share the congratulations, well merited, with his crews and with his teams. So the mood, you can see, is a first replay of Vega taking off. The mood, as you can see, very buoyant here in Jupiter and all across the Space Center at all the points and posts where people are working or following the launcher and the satellites. Work is just beginning or soon will be beginning at all the different ground stations and at other centers around the world where the satellite's first maneuvers are being monitored. Another replay closer. So from the tense minutes, moments ago, you see the change of mood here in Jupiter. And this is echoed, of course, at all the outposts and offices where people involved in the decade-long Vega project are following the happy outcome of events. We're waiting now for the traditional post-launch speeches. We will be hearing from Jean-Jacques Dordain, ESA's Director General, from Jean-Yves Le Gall, Chairman of Arianespace, will also be speaking, as I believe Joel Barr, head of the space base, and I believe also Yannick Descartes, President of the French Space Agency CNES. And we are supposed also to be hearing from an Italian minister by telephone link from Rome. So all that coming up. Don't go away. These gentlemen, those present today, of course, not the minister, will shortly be making their ways out from the fishbowl to join us on this side of Jupiter. The podium and its microphones are being set up for them now. Messieurs Dordain, Le Gall, Barr, Escata, and others are no doubt continuing to extend and receive congratulations, shaking hands all around. The champagne and the cigars will no doubt be forthcoming. So a very, very jubilant end to the 10 years' work as the teams in the fishbowl continue to applaud the top management posing for pictures here in Jupiter. You're looking inside the fishbowl there where people are taking pictures, but on this side of the red bars you have equally a 5-deep group of fans and well-wishers snapping away, looking into the Jupiter Mission Control room at this very important historic moment for European space and for the Italians and for everyone. As we mentioned, the Perth downrange tracking station helping us out with the the tracking, NASA helping out, stations all around the world, the space family, the international space family, of course, always very cooperative, whether it's NASA cooperating with ESA or vice versa, or the Russians. One big space family, and giving everybody cause for jubilation tonight. So the big news from Kourou is that Vega has delivered on her maiden voyage, successfully releasing her 9 satellites, LARES and ALMASat, and the 7 CubeSats. Another replay. You can relive those moments over an hour ago as Vega took off. I see Jean-Yves Le Gall is on this side of the hall here. He's making his way to the podium. We're waiting for Jean-Jacques Dordain and the other gentlemen who will be giving us their thoughts and their reactions and their emotions on this rather emotional morning, I should say, here in Kourou. We will be hearing, as we said, from the Italian Minister for Space and Industry, I believe. I may have his title wrong. Antonio Fabrizi, coming up towards the podium. The gentlemen who are making their way to the podium are not making a very rapid progress, because at every 1 or 2 steps they're stopping to shake hands or hug their colleagues. So we may have a bit of a wait before they finally get to the microphone, but I think they're all on this side of the Jupiter Mission Control. Most of the hall on its feet, most of the invited guests, the VIPs here, part of the program, working on it in some way for over a decade. We're waiting for our speeches. Just a word on while we're waiting, or the word, the weather conditions. Oh, you saw on the camera, well, we'll get back to the weather, because I see Jean-Jacques Dordain has made it to the podium, and he's testing the microphones. So we should be hearing from him. At his side, Jean-Yves Le Gall and Antonio Fabrizi. These 3 gentlemen for sure will be speaking. Jean-Jacques Dordain will be first. I think he's ready. Next to him, Yannick Descata, the president of the French Space Agency, CNES. Visibility was very good, as you noticed on the replays. In fact, there was talk that if visibility had been bad, they didn't want to launch, because they wanted to see Vega's behavior between the ground and 100 meters. It's so very important on this qualification flight with all the cameras. But fortunately, that did not occur. And we had, as you saw, a perfect liftoff and a perfect flight. The ESA people are, I think, trying to get the people to go back to their seats, because they don't want to start the speeches while everybody is still milling around. A lot of emotion here at the space base for this first flight. I haven't seen anything like this for a long, long time, I must admit. Jean-Jacques Dordain, I think, is ready. Mr. Dordain, you have the floor.
Michel, assieds-toi.
Jean-Jacques Dordain, Director General of the European Space Agency.
Bon, Michel. Okay, so, fatto. Persino meglio dei miei sogni. È nato un nuovo membro della famiglia dei
A new member of the launcher family has been born.
Che sarebbe stato l'ultimo giorno di uno sviluppo durato.
I told you that it was the last day of a period of 10 years development. That is where we are today. We now have a qualification flight which goes to show that Italian proverbs are much better than any French superstitions or superstitions of my own. On Friday and on Tuesday, according to what the Italians say, you shouldn't travel, nor should you begin any artistic venture. Today is the first day of a new operational life, which doubtless will be a long and successful one. Vega is a launcher that's necessary for us at ESA. We've already reserved 6 launchers. These launchers will be operated by Arianespace, and I have to say that I'm absolutely delighted, and I'm looking now for Mr. Fabrizi. I really am pleased that we can now symbolically hand over the new launcher to Jean-Yves Le Gall.
Dopo avergli consegnato le chiavi della base
So, now having handed over the keys to the Soyuz launch range, that was on the 7th of May of last year, I can now hand over the keys to Vega. So we have Ariane, Soyuz and Vega, a very fine family. And I hope you're going to take good care of the members of that family. I am sure today that there are more fathers of Vega now than there were 10 years back, and that in itself is a sign of success. I'd very much like to thank particularly the initial founding fathers, those who faced up to the risks and battled against resistance, particularly those who've already left us, Antonio Rodota and Carlo Bongiorno. I hope that wherever they are, that they have been able to see Vega, and that Vega passed to greet them.
Because I have to keep some training. I shall switch into English now to thank the 7 participating states, which have entrusted ESA to develop this new launcher. Obviously starting by Italy, but also France, Belgium, Spain, Switzerland, the Netherlands and Sweden. Thank you very much for your trust. Thank you very much for your support. I wish to thank all those who have given 10 years of their life to achieve today's event. It was not easy. Vega may be a small launcher, but as I said yesterday, it includes a lot of innovations, technological innovation, funding innovation, industrial innovation, management innovation, a lot of difficulties. But you have succeeded thanks to your expertise, your work, and your team spirit that we could measure in the last years and months. I cannot list here the names of all those who have contributed to the success of today. Anyway, those who have not contributed regret already. And those who have contributed in a way, they can be proud of what they have done. Those who have contributed are from industry from Europe, from Arianespace, from CSG. Thank you very much, CSG, because I know, Joel, that it was a difficult mission to start, but you made it also. From CNES, from ASI, from ESA, without forgetting the members of the review. You are all great. Now I would like to conclude with the most important heritage from the development of Vega, a brand new generation of competences. I can tell you that this morning I have been struck by the young age of the people taking care of Vega. They are very young, but they are already very competent. And this is on their competence that we shall build the future. And let me tell you a personal story for these young engineers. Vega is certainly the last launcher of which I shall participate to the qualification. Vega is a 3 solid stage launcher. And I would like to tell them that I have started my career here in Kourou 40 years ago with Diamant B, which was a 3-stage launcher. So I wish all these young engineers as much pleasure and as much pride that I have felt since then. E non ancora finita, grazie mille.
We were saying you have seen, I am spoken in Italian, so Vega has done the first miracle. Let Jean-Jacques speak Italian, which was a great thing. So the only thing I can say is that we are proud to have participated with all of you in this new adventure, in this new era, the starting of this new launcher, and of the activities that will belong to this new launcher. I must say that we are proud, all the 7 countries who participated are proud, I'm pretty sure. And as Jean-Jacques said, we are ready to have with us other fathers. And in effect, I was called by Jan Werner saying that Germany, after the success, will join Vega. That is a great thing. I think that we should be satisfied of this. So we should embrace him and have him with us in such a way that the real rev, I could say, of Vega, of the initial period of Vega, by the initiators of all the activities in the field of launchers in Italy, with Luigi Broglio, was that all European countries could profit of these new ideas, of the new developments. So I'm pretty sure that with this effort, with this strong effort, we will have all the other countries ready to join us and ameliorate and enhance this success with this new generation. And since I am the only Italian with, let's say, at this level with this success, let me switch to French. So, just seulement pour remercier.
I'd quite simply like to thank all of the French friends here, Jean-Jacques, Jean-Yves Le Gall, Yannick Descata, Michel Aymar. I'm not too sure where he is. Yes, there he is. Joël Barre. There are many French colleagues and friends who've worked with us. And I'm extremely pleased that the Franco-Italian alliance this time round has not turned out to be like a football match. And the result at the end of the day is a good one for everyone in Europe. Thank you. Right, well, I'm going to speak French because I haven't had time to learn Italian yet. So I'd like to thank you, Director General, and thank you, President. I, in turn, would also like to say how moved I am by this first perfect launch of Vega. Once again, the Guyana Space Center is the scene of veritable exploits for Europe, a Europe of enterprise, of success, and a Europe that meets every challenge. I would therefore like to congratulate and thank all of those who have contributed to the success, obviously the European Space Agency and its launcher directorate in Paris and in Frascati. Thank you also to the Italian Space Agency, and I too would like to give a special mention to Professor Carlo Bongiorno, to whom we owe so much. Thanks also to the CNES in France and its launcher directorate, and also thanks to the CSG, the Guyana Space Center. My thanks go too to all of the industrial partners in the Vega program who see the result of 10 years hard work and who really contributed to this first launch. This launch, this success, is but the first in what's going to be a long series because, as you know, Arianespace included Vega already in the past in its service and solutions offer. That is because this is a small launcher that has been long awaited by the market. We're off to a good start because we've already signed 2 commercial contracts to launch from Vega, with Vega, the Sentinel spacecraft, and we've started the manufacture of 5 further launches in the context of the Verta contract. My thanks go to, together with my congratulations to the passengers, in other words, the Italian Space Agency with LARES, the University of Bologna with ALMASat, and the different European universities involved in the 7 picosatellites. You've all placed your money on Vega and you've won the bet. Well done. And without further ado, I'd like to hand over to the Italian Minister of Research, who I think has a message to share with us.
Vega costituisce certamente un grande successo. È l'affermazione del perfetto connubio tra ricerca, ingegno ed industria italiana. Per l'Italia è la conferma del ruolo di protagonista in un settore fortemente avanzato come quello dello spazio. Vega sarà per il nostro continente un progetto ad elevata efficienza, sia economica per l'offerta di servizi collegati al lancio, sia in generale per le tecnologie che ne deriveranno. E per l'Italia si potrà trasformare in un rilevante ritorno industriale, progettuale e anche occupazionale. Grazie a Vega in Italia si potrà creare un vero polo di eccellenza che farà da traino alle tecnologie di frontiera. Guardiamo quindi con grande fierezza al lancio di Vega. Vorrei infine ringraziare il sistema della ricerca italiana e di tutte le aziende del settore dello spazio del nostro Paese per il loro contributo e per il raggiungimento di questo straordinario risultato.
So, thank you and congratulations for this tremendous work and contribution.
Bien. Donc, je crois que cela va terminer.
I think that brings us to the end of the video transmission, and we'll be back here in under a month from now, following today's tremendous success and the tremendous success of the end of last year. We will be back with Ariane 5 on the 9th of March with the the milestone mission, the launch of the third ATV, and by coincidence, it bears the name of a leading Italian scientist, Edoardo Amaldi. So thank you and well done once again.
There you have it. Davide, any last words?
It's really an amazing success. I was mentioning before to Josh about the statistics of the first qualification flights since the early days, and I think it was 45%, I told you, so I think we really did a good job.
I think everybody agrees with you. Vega's first launch, a resounding success, and over these fine shots of the final launch replay, we'll say goodbye. Europe now with a full family of launch vehicles, Ariane 5 for the heavy ones, Soyuz for the medium-sized passengers, and Vega for the light lift vehicles. Next launch, another milestone, the third ATV to the International Space Station, March 9th. We'll be here. We hope you will be too. Till then, Joshua Jampol with Davide Nicolini Avesa. Thanks for being with us. We'll see you next time. Goodbye, everybody.